Thank you for coming today. This is Miguel and I'm Fabian. We are both working in the computer science and software engineering department, and we will try to convince you that there is a life beyond the IT crowds and Mr. Robot. Okay? Maybe. As a cliffhanger that actually looked like working to make you coming so many today. We need you to avoid having a world where robots will take over us. We really need you to design software which won't put us in jail or eat us or send us to the moon or whatever. So we really need you guys to build software. But, well, what these computer guys are actually doing? What are we doing? Yeah, that's a good question. Do you think we are doing what these IT crowd guys, I don't know if you know about these TV shows, but it's hilarious. Do you think we are just answering the phone and just telling people when they have troubles with their computers to turning it off and turning it on again to just try to restart Windows and waiting ages for his updates? No, we're not. Yeah, as you could, I think as you could imagine. Do you think we are kind of hackers or crackers spending our life threatening the world to make everything blowing? Yes, some of us are doing it, but not all of us, okay? We are not trying to just be harmful to the world. Probably the opposite. Actually, the robot name was created from some old, an old play, a theater play. And already at that time, so in the early 20th century, this concept of robots was already scary, okay? And if you are listening to Elon Musk, which is the CEO of Tesla, so the cars, and also SpaceX, so the guy that is trying to send rockets for commercial reasons. We can be scary from robots and artificial intelligences, but actually these guys are trying to scare just the world. It's not, the reality is not like that. Far, far, far away from that. Just a couple of funny facts that when you delete something on your computer, on your drive, actually it's not really deleted. It's just we just lost this reference. So if you want to delete something, like if you have some pictures of you that you don't want to show when you will be 30 or 25 when you will get married because you had a strange haircut, or you had huge glasses, or you had the most the less beautiful uniform at school, be careful. Just try to override stuff on your disk. Also, there is a funny stuff that is called the constant variable, but it doesn't vary in computer science. We have many facts like this that you will learn. And probably, but I don't see a lot of parents here, so for you it's okay, guys, but actually in computer science, a parent can just kill his children without being charged or sued in jails. So this is quite funny, especially for me being a parent. And we are seeing trees in the opposite way of normal doing. So for us, the root of the tree is at the top of the tree. And actually, I'm quite happy to see so many girls and ladies here, because if Miguel and I are here today, it's because two people, a guy and a lady, invented computer science almost 200 years ago by having Charles Babbage creating a machine and Lady Lovelace creating the way to talk to this machine, how we could create algorithms.
Okay, but a key word in computer science, in software engineering, it's coding. Coding, it's the action of write code that can be read by a machine and act following the instructions that we wrote. Coding is very important in this area, and for that reason, I like to show you this graphic. There's how many lines of code we need to develop those things. For example, look, well, hundreds of thousands, no? Less than 1,000, hundreds of thousands, a pacemaker. It's a thing that puts in your, instead of a heart, and that thing has software, so has lines of code, less than 100,000. But somebody of you have used Photoshop or knows what is Photoshop? Yes, the software, the Adobe Illustrator or things like that. Well, look how many lines of code. This is a web browser, and this thing, the space shuttle, well, that thing can come and go to the space. That's nice. But there's not a lot of code there. Let's change the scale and let's talk about millions of lines of code. We imagine if you want to become a software engineer or a computer scientist, you want to write code. So we need a lot of people with that ability, coding. And look at this. The Boeing 787, do you know that plane? No? Yes? Whatever? Okay, doesn't matter. We have less than 10 million, it's 6.5 millions of lines of code for only the support systems of the plane. But if we want that that plane can fly, we need the double lines of code. Look at this. If without those 6, 7 millions more of lines of code, the plane can't fly. It's a lot of code. Imagine if we make a mistake and put some error in that code, what will happen? Crash, maybe crash, no? In the worst case. There's a lot of histories of famous mistakes or famous heroes in software. There's, I think it's the Mariner, I think a rocket that was launched to the space, and the work of some guy, some software engineer, was to translate the formula in a piece of paper to the code in some programming language. He made a mistake, so the road was calculated wrong, and that thing explodes in the middle of the air. That's a very, very expensive mistake. It was only one line of code, one variable that varies or that wasn't constant. Look, do you use Facebook a lot? We need like more than 60 million lines of code just to post some, the major part of time, useful or not so useful information. We need a lot of code there. Think if I have an error there, privacy issues come arise. What happens if I share something that I don't want to share with everybody, but at the end, when I ask for a job, well, my future boss looks that publication, that post, things like that can happen. But, well, there's a lot of code in this discipline. It's like a new language to learn, like English, Spanish, whatever. But now you will have the ability to talk with the machines. And the machine, it's a phrase, the machine is dumb. The machines do only what you tell in that code. So you have the power to write a few lines and the machines can obey you. What we do? What do we do? Listen to customers and offer expertise in this field. We have a lot of areas like security, databases, visual, computer vision, a lot of things that computer science applies. we design, build, and grow up solutions. Imagine that software exists to solve a problem. Software doesn't live by itself. Each piece of software that you interact solves a problem. More of those problems are solving cutting-edge problems, so it's a challenging task to do that things. If you decide to study with us, we have 3 majors. We have computer science in the department, software engineering and data science. The computer science, it's a 3-year bachelor degree, and you have a lot of elective courses to direct your interests. I can show you at the end of the presentation all the areas that we manage. If you like software engineering, it's a 4-year bachelor degree, and it includes a practical work experience. We invite the students to go outside, to go to the industry and solve real problems in real situations with real customers, and everything it's real. It's a very interesting experience, because it's not only what the lecturer said or what is in the book written, it's about real things. And also we have data science. This is a popular one. Do you know the term big data? Yes? No? Well, it involves statistics and also computing. It's the ability to manage a huge amount of data and to give information, important information, to the people who takes decisions. And that involves a lot of money most of the time. What's the difference between computer science and software engineering? For example, in Mexico, we don't have yet. Oh, well, I'm from Mexico. For that reason, I say what about Mexico. We don't have a difference yet about software engineering and computer science. The computer science is focused on the theory and how we use those theory in solving problems. By the other way, the software engineering, it's about building something that solves the problems. It's theory and practice. It's a very nice mix. But in software engineering, it has an element, a strong element, because about teamwork. If you are able to work in team, you can solve bigger problems, bigger challenges. You need people who has expertise in other areas, and then when you join a team, you are a powerful team, rather than be alone. Both majors are incredibly demanded professions. There's a lot of work outside for software engineering and computer science. Why? Because it can apply for every area of your interest. If you like geography, you can work with maps and GPS and geographical information systems. If you like the human body, for example, you can work with medical people, with clinicians, and solve problems applying computer vision, for example, or whatever of software engineering and computer science in a particular area of knowledge. So it's a very interesting thing because when we solve a problem, the common thing is that at the beginning, the computer science, something like me, doesn't know anything about the problem that he's solving, but during the project, you are learning a lot of things about that particular area, and you can solve things like, for example, we are in the 3rd year right now in this, the 3rd year course of software engineers are creating a system to improve the transplants in New Zealand. So how you can improve the match between an organ and a receiver? We want that the people who receives an organ lives longer, no? Well, let's decide who is the best candidate to receive an organ. That's a medical problem. Yes, it's a medical problem, but without software, it will be very hard to solve in an amount of time that it's useful for the patients, for example. Also, they have a final year project, often in the industry-based, so it's real, working on a real-world problem, learning from professionals who works already there, and you develop skills. For example, the teamwork skill, it's a very it's a must for a software engineer. And there's, well, if you like sports, do you like what sport? What sport do you like? Rugby? No? Well, for example, imagine that we can measure what's the distance that a player runs in a game, how many balls touches in those games, how many of them was a right pass or he gives the ball to the opposite team. Things like that are information in order to make decisions, important decisions. Sports, well, maybe it's not so critical, but I say that about healthcare problems, we solve healthcare problems that helps people, and it's a motivation for software engineering. I like that slide. Look, all the fields of computer science. What do you like video games? Who plays video games? Do you want to develop video games or test video games? Things like that. Well, in order to create a video game, we need artificial intelligence. Imagine that, I don't know, I played a lot of years ago Resident Evil. Did you play that thing? Imagine if the monster has a bad artificial intelligence. Well, you can kill it very easy. We need to give challenge to the players. So we need good artificial intelligence to that guy. So we have to know about artificial intelligence in order to develop a good game, a good video game. What else do you like? Maybe, also in video games, we need simulations. Well, there's the software engineering. If you like things more focused like the operating systems, everybody uses Windows here, I think. Well, maybe we can use another, or iOS. I don't like iOS, but doesn't matter. Or develop apps. Every person in this room uses apps. Yes, right? Do you want to develop an app? For example, an app that reminds you when it's raining that you forgot your umbrella. It's a very easy to create app. Very useful. Well, you can learn in the computer science and software engineering department to solve that funny and kind of things. There's a lot of theory for that side. Also, theory is important. It's the base of everything. But I want to show, with this slide, I want to show that there are a lot of opportunities if you know or if you are interested in computer science or software engineering. And what you need if you want to join us someday? Mathematics. Obviously, we need mathematics. You need communication skills. It's a teamwork-based, just as a team-based work, sorry. So you need good communication skills. If you can't communicate what's the problem or the solution, if you can't describe to the other people in your team, well, it will be difficult. You need logical thinking, be creative. But if you don't have programming experience yet, it doesn't matter. You will learn later, right? Another ingredient to this recipe is motivation. If you are motivated about what you are doing, it will be easier. You are enjoying what you are doing. So no matter if you choose computer science, software engineering, or anything else, I advise you choose what you motivate you. Yes? It's a very, for me works. So you have questions? Questions? Whatever?
Come on, you have questions.
No? I have one question. What do you want to study? What are your first 3 options, for example? No? No answers? No questions?
If you want to go to the data science, so if you want to deal with data and to try to extract knowledge from data, then you need statistics. But anyway, you don't need a good background on statistics because you will at least learn about statistics afterwards. But yeah, if you don't like to see formulas and graphs, and if you are really allergic to mathematics, yeah, try to find something else. But otherwise, yeah, the idea is to start from the basis, so you will learn about it. Okay. Another one.
Does software engineering go hand in hand with computer engineering?
Not really. Computer engineering is more about how you build a computer, how you design the CPU, how you design the connectors. Software engineering, we are just using what the computer engineering guys are doing. We're just using it as a tool. Yep.
So for like software engineering, more specifically that, would you say courses like product design would also be useful for getting into that course, since it's kind of that building products?
Product design is also a different matter. They just created this this field now here, so there is a specific graduation in product design. So this is a bit different again.
Okay, I'm just asking if like the high school product design would be useful. That's the stuff you can do.
Oh, this is a really complicated question. I must admit, I don't know. So you have to ask the product design marketers, because they will probably be able to sell their own stuff. But yeah, I can't really tell you. Yeah, I've seen a hand over there. Yep, no? No, I don't. No other questions? The last one? Tiny one? No? Okay. Thank you for coming. I hope we convinced at least one or two guys. At least one or two guys. Yeah. If you want to go to Australia afterwards, just do computer science. They are hiring a lot of students from us. If you like big spiders and snakes. Thank you.